All right, guys. So today, AP Test Prep Level 3B, I think. I've done so many videos, I've lost count. Today, we are going to be talking about properties from IMS. Okay. These properties include boiling point, melting point, vapor pressure, one more. There's I guess surface tension could be put in there, but we'll leave it at that for now. That's the easy ones. Okay. So these are determined by the products, the reactants, not reactants, the compound. There we go. The compound's intermolecular forces. Okay. So for intermolecular forces, the stronger the intermolecular force, the higher the melting and boiling point. Stronger IMF equals stronger BP and NP. And then the opposite, a stronger IMF would give a lower vapor pressure. Okay, and it all has to do with how strongly things are being held together. Okay, so if we have methane here, and then we also have 10. That's an A. This is butane. Okay. If we have methane versus butane, okay, which one has the higher intermolecular forces? It would be the butane. And so butane should have a higher boiling point, melting point, and a lower vapor pressure. Okay, now if you're confused on what vapor pressure is, a good reminder is to say that if you have a container, a closed container, okay, with the liquid of whatever compound you want, okay, and you leave it, the vapor pressure would be the amount of pressure from the gas particles up above. Okay, now if you have something with a, let's see, 7, 1, 2, 3, 4, 5, 6, 7. All right, now if you have a container that let's say the purple liquid and the green liquid, okay, the green liquid has a lower vapor pressure than the purple liquid, which has a higher vapor pressure. If you have a higher vapor pressure, that means that at the same temperature, these are both at 298 Kelvin, or room temperature, the thing with the higher vapor pressure is going to have more gaseous particles and thus more gas pressure in the container. Okay. Something with a low intermolecular force will allow more gas particles from the liquid to be transferred up into the open area there. And if there's more gas particles there, then there's a higher pressure. And so that vapor, the pressure it creates, that's what's called the vapor pressure. Okay. So it's important to be able to tell how something, which, like the trend of strong versus not strong intermolecular forces. Okay. So let's say okay, C or methanol here versus methane. Which one is stronger when it bonds with itself? Okay, the stronger one would be it would be methanol, because methanol can hydrogen bond with itself. Another molecule of methanol. I shouldn't say with itself. Okay, so there's a hydrogen bond here. However, methane only has London dispersion forces, and so it has a weaker intermolecular forces. So the boiling point, higher, melting point, higher, vapor pressure, lower. BP, we'll keep it BP low, MP low, VP low. Okay. Now let's say I don't even know if this is a real compound, but dimethanol. Say that. Would it have a higher or a lower boiling point, or let's say a higher or a lower strength and intermolecular force than regular methanol? It should have a higher hydrogen bonding because it has one spot and two spots to actually hydrogen bond. Okay, not just the one that is on methanol. Okay, dimethanol would have a higher IMF, and it would have higher boiling point, melting point, and lower vapor pressure. Excuse me. All right, so that's it. If you have questions, let me know. This is going to transition us into level 3C, and that is ideal gases. So stay tuned for that video.